Pleasant day. This is your Captain RT, Serexen Barosa, and I'm here to discuss with you how to set the ServoU ventilator in various modes of ventilation. So I will basically not explain, the guidelines on how to set, but rather just to go through the screen and go through the parameters that we need to set during each mode of ventilation. Okay, so before you begin, just make sure that all your connections for gas supply and electricity are connected, and then you have done the ventilator, had undergone a pre-use check and patient circuit test, and your breathing circuit is connected. So with the patient circuit test passed, both pre-use and patient circuit test, then you're sure that your circuit is have the integrity. Okay, so no leaks present. Okay, now before you begin setting the modes and the parameters, just check your patient data, and then you have to select what patient category you are going to ventilate, and then enter on the gender. Okay, in this case male, and then enter the weight, let's say 60 kg actual weight, then enter the height. Okay, when you enter those three parameters, okay, or demographics, the ventilator basically calculates, okay, the predicted body weight, or we know it most commonly as the ideal body weight of your patient. So the ideal body weight, whether you are ventilating in volume control or pressure control, is the target tidal volume, in ml per kg. So usually now we are using at least 7 to 8 ml per kg for most ventilation needs of our patient. But in the case, of course, of ARDS patients, or those with by PF ratio has ARDS, then we can set our target tidal volume based on the predicted body weight at the lower range of, let's say, 6 to 7, or 5 to 6, or 4 to 6, usually 4 to 6 ml per kg. Okay, that is, of course, as we know it, for lung protective strategy during ventilation of patients with ARDS, or in some lung conditions where you need to protect the lungs from further injury. So once we're done with the patient data, you just press okay, and then you go to the main screen. As you can see, you can select again the type of patient you want to ventilate. If you are providing non-invasive or invasive, in this case we're providing for invasive ventilation, that means intubated patients. And then we go to the modes of ventilation. You just press the modes of ventilation, and then from here you can see again, you can choose invasive, non-invasive, and then you have the controlled modes, or what these modes are providing mandatory breaths, either triggered by the ventilator or triggered by the patient. Then the supported modes, we have pressure support, CPAP, volume support, and NAVA. So supported modes, basically these are the spontaneous modes in some of the ventilators. So, and then we have the interactive modes. In the interactive modes, we have the following. So we have 3 auto modes, PC, that changes into pressure support and back. Then we have PRVC that goes back and forth to volume support. So PRVC, volume support to PRVC breaths. And then we have volume control that transitions into volume support, or from volume support to volume control. Okay, so these are auto mode. Okay, and then we have, of course, the SIMB in pressure control plus pressure support, and then we have SIMB PRVC plus pressure support, and SIMB volume control plus pressure support. Okay, so let's select volume control. When you select a mode, automatically the ventilator screen changes into the parameters active in that particular mode. So in this case, in volume control, we have the following: the auto concentration, the PEEP, the RR, the tidal volume, IE ratio, pause, inspiratory rise, and trigger. Okay, or trigger, or the sensitivity level. So once you press each, there are associated, like for example, the IE ratio, you see both the graphical representation of the flow on inspiration and expiration, and as you can see here, it shows you that the inspiration is terminated at, let's say, the 0.93 seconds at, let's say, around 40 to 50% of the flow. Okay, so the pause time, the inspiratory rise, and the trigger. Okay, so basically those are the parameters that you need to set when you select volume control in the ServoU. So it may be different from the other mechanical ventilation. Okay, let's say we select 40, we then increase or decrease using the plus or minus sign, or you just run through your fingers. Okay, run through it. Okay, as you can see here, green, then it changes to yellow. Okay, well, simply because we do believe that or by evidence based, that anywhere from 60 and above, or over 60 of FiO2 can expose the patient to the dangers of oxygen toxicity. So that's why, and it's providing us with a Q, yellow, so it is cautioning us to increase the FiO2. So it depends basically on your patient. So let's say it is set to 50. Okay, then we go to PEEP. Okay, in PEEP the same thing, so we can lower the PEEP. As you can see in this ventilator, see, the minimum is 5. Okay, the minimum is basically 5 centimeter H2O. Okay, so let's set the minimum. Then the RR. Okay, now you can see for the initial settings, basically the ventilator provide you with recommended, but you can manipulate that. Okay, now as you move the main parameter setting, we have here, of course, these are also settings, but these are calculated values based on your the manually set parameters. So as you can see here, we have the following: the inspiratory time, the minute volume, and the flow. So the respiratory rate affects all these parameters: the inspiratory time, minute volume, and flow. Okay, in let's say we set to 15. Okay, if we set the rate to 15, we have those. So okay, now when you press the tidal volume, you will see on the beside the tidal volume setting is the target tidal volume. So at the moment we are at 6.7 ml per kg. Okay, so let's say if we set we require that the patient have 8 ml per kg of target tidal volume, then we could increase this. Okay, so the ventilator basically doing it in increments of 10. Okay, so now we are on a 7.9 ml per kg target, so we can press check or accept. But as you can see also that when you manipulate the tidal volume, your minute volume and flow is changing. Okay, so basically an increase in tidal volume leads to an increase in both flow and minute tidal volume. Okay, a decrease in tidal volume leads to decrease in flow and decrease in minute volume. Okay, so let's say we target 7.9 ml per kg. Okay, then in most part the auto concentration, PEEP, RR, and tidal volume, these are the parameters ordered by the physicians. Okay, and the rest of the parameters that is manually set, we respiratory therapists could recommend or manipulate these settings in order to provide better synchrony with the breath provided by the ventilator to the patient. So we can achieve by setting this, we can achieve better patient ventilator interaction when it comes to the mandatory breath delivery. But of course it depends on your patient. If patient is fully sedated, then you can set the usual ratio and the trigger flow, etc. Okay, so we go to the IE ratio. The IE ratio, as you can see, when you manipulate it, changes your inspiratory time and flow. Okay, so if you increase the ratio, see, as basically here, okay, basically here you can see that if you reach the limit that you want, the normal is 1:2, that's basically the usual limit. But if you want to increase more the ratio, you can just okay, see, I cannot increase anymore the ratio. There is a plus sign, you can press that and then you can manipulate. Okay, so yeah, that is lower limit reached by maximum flow. Now you can see that if you increase the ratio between inspiration and expiration, you shorten the inspiratory time and then you increase the flow. So okay, so let's say, okay, now let's say we keep that to 1:2, we lock it and then we accept it. So with 1:2, that gives us 0.93 seconds inspiratory time and a flow of 33.9 ml per liters per minute. Let's accept. Let's say pause time. Okay, the pause time, okay, or percent T pause, when manipulated, when we increase this, we basically decrease the inspiratory time. Okay. Okay. So basically, if we don't want any pause, we want it to 0. So as you can see here, that gives us 1.33 seconds. So it made the inspiratory time longer, and therefore your flow becomes lower. If you want the ventilator to have a pause after it delivers the desired volume you have, it's like a hold, inspiratory hold in some of the ventilators. You can increase, okay, the pause, so you can also manipulate the inspiratory time, and by that you can also increase the flow. Okay. And then we have, of course, the rise time. The rise time is the initial basically the initial delivery of your desired target volume, or the initial delivery of the flow. So you can increase or decrease that. If you decrease the inspiratory rise, you basically decrease the flow rate. If you increase the inspiratory rise, you increase the flow. Okay. At the bottom of the screen, you could see the fast rise and slow rise. So let's say you want a slow rise, so will give you more flow. Okay. And then of course your trigger. So usually we set their trigger at 2. So you can see that the trigger, okay, that's your minimum. If you want it, you can again press plus, and then you could go all the way. But you see the red mark means that your ventilator becomes overly sensitive, and usually we can keep that at around 1 liter per minute, or 2 liters. Now you can see that the ventilator automatically changes from flow triggered to pressure triggering. As you can see that the number indicator changes from liters per minute to centimeter H2, and even the graph shows that you are changing, okay, from flow to pressure. So usually we have you can set the ventilator to -1 or -2. It's like it has become a common standard, okay, setting for the flow 1 to 2 liters per minute. Okay, and then for pressure we have 1, -1, and -2. Okay, when you go further, as you can see red, that means that again the ventilator has become less sensitive to patient effort. So let's say keep it to -2, or flow of 2. Okay, and then once you're done, you just press accept. Okay, and then start ventilation. And as you can see, now you can connect your ventilator to your patient or your breathing circuit. As you can see, there's a red light showing some alarm. Okay, so you observe the mechanical ventilator with several breaths, and now you can set the alarm limits. Okay, so you go to the alarm limits. Okay, you can silence your ventilator, and as you can see here, there are 4 basic alarm parameters. You have your peak pressure alarm, you have your PEEP alarm, total respiratory rate alarm, or total frequency alarm, and then your minute volume. Okay, so with the peak pressure, you can use the one that is in your the guidelines. Students can use the guidelines in the introduction to mechanical ventilation manual when setting for the peak pressure alarm. Okay, so you refer to your manuals when setting the peak pressure alarm. Okay, so you can manipulate that. As you can see here, you only have a high peak pressure alarm. Okay, high peak pressure alarm limit. So you observe how much is your in this case you have 20. Okay, so you can add like 5 to 10, or just use the one in the manual. Okay, let's say most commonly in the hospital they set at 40 peak pressure. Okay, check. And then when you go to the PEEP alarm, the presence of the two bars suggests that this you have a low PEEP alarm limit and the high PEEP alarm limit. Okay, so again you can use the guideline from your manual to change the setting also. Okay. Remember our PEEP is 5, which is signified by this arrow, the broken arrow. Okay, our lower limit is this one, so you can set it at 2 plus or minus 2. Okay, so 7. Because imagine that if you set it a higher limit, you are exposing the patient to the dangers of auto PEEP, and that basically caused by air trapping and can cause hyperinflation. Okay, then we have the respiratory rate. Okay, the respiratory rate, we have here a low RR and high respiratory rate alarm. So basically, when in your guideline, we can begin at depending on your, we can begin at 20. Okay, depending on, most commonly because your settings, they may start at 16, at 12, like that. So we can start at 20 and then maximum is 40. Okay, so usually that is our guide. You can start from 20 and then maximum of 40. For the low, of course, remember that if you are in volume control mode, so this alarm will not really be active, simply because the ventilator will be delivering your minimum respiratory rate as ventilator in volume control is time triggered and patient triggered, so it's time triggered will be the minimum setting. So in this case, we set it to an RR of, you can see from here, but I think it's 15. And then of course your minute volume alarm. And the minute volume alarm, you usually add like around 2 liters. Okay, 2 liters above your observed minute volume, which in this case your minute volume is 6.9, so you basically add 2 liters. But for the lower minute volume alarm, you need to get the 10% to 20% of your minute volume. So you basically calculate how much is 10%, a range of 10% to 20% of your, and then once you get the volume, 10 to 20% of the volume from the total minute volume observed, you subtract it again to your minute volume. Okay, so in this case, okay, 6.9. So that means you have around 690. Okay. So this is a minute volume of 6,900. So basically only around 6.2 or 6.3 or 6.2. Okay, this is difficult 6 point, but this is only in increments of 5, so you would rather want to put it on 6, but that's okay. Let's say it's 20%, and then here you can add again plus 2 liters. Okay, so let's say 8.5 to 6, 9. Let's go by 9. Yeah, okay, then accept. Okay, and then accept. Okay, so now those are the necessary parameters that is being set in volume controlled, and also the how to set the alarm. So by the way, the alarm, it doesn't matter which mode actually you are in. So you can use the guidelines provided in the manual for setting the alarm limits. Okay. So thank you so much. That is volume control, assist control mode in the ServoU market ventilator.